Hi guys, how are you doing? And it's Jalaj Aurora here again, back with another video today. And today we'll be doing C1.5, which is all about the history of the atom. Now, before I start, I just wanted to kind of let you know about something about the GCSE chemistry course, like the whole content that I'll be teaching from start to finish. So basically, I was very interested in how long it would take. So today I woke up in the morning and then I kind of counted how many sections there were in the whole kind of GCSE chemistry course, and for AQA, using this book, this revision guide. So this revision guide right here, I'll show it again, the one I'm using. But there are 99 sections basically in the book. So that means 99 videos from the 16th of July 2020 to my final video, which would be basically on the 23rd of October 2020. So it'll take about just over 3 months to finish the whole kind of content, and that's pretty good. I think for the it's kind of quite a lot of content in chemistry, and to do that in 3 months is quite good, I think. So that should be good. Should be done in just over 3 months. But basically today we're doing C1.5, which is the history of the atom. And this is one of the kind of very few things that I think not very logical. You just kind of have to remember. I think it's worth actually spending time remembering this kind of stuff, because it can quite easily be a 4 to 6 marker in the exam. And if you've learnt this stuff that I'll be teaching today, or not teaching, I'll be kind of going over, because obviously these videos are for revision purposes, not kind of teaching the content purposes. Not for those purposes. So kind of if you see this kind of basic overview, hopefully it should kind of, and you know this content very well, this part of the book. If it comes in the exam, you're just laughing, isn't it? Because you know how to do it, and you could just do it then. But basically today we're learning about C1.5, history of the atom. Let me make myself clear. So basically, the ancient Greeks were the first to have ideas about the atom. So obviously they were the first kind of people to kind of have some kind of ideas about atoms, and they were the ancient Greeks. Sorry about that there. But in the early 1800s, Dalton, his name is John Dalton, linked his ideas to strong experimental evidence, and Dalton suggested that atoms were tiny, hard spheres. Now, these atoms could not be split or were divided or split. He said these atoms cannot be divided or split. And he also said that, it doesn't say it here, but he also said that atoms were the smallest, kind of particle ever, which is, obviously we know it's not true. We have subatomic particles like protons, neutrons, electrons, which we're going to come on to soon. So that's what he thought in the early 1800s. He kind of put forward this idea that atoms were kind of, tiny hard spheres that could not be divided or split. And he kind of, put that forward, and the fact that they were the smallest thing. And then but the fact that they could not be divided kind of itself suggests that they are the smallest thing if you can't divide something further. But that's obviously not true. We know that. So at the end of the 1800s, then J.J. Thomson, it says Thomson here, but J.J. Thomson is his name actually, discovered a kind of a tiny negatively charged particle called the electron. So J.J. is obviously, that J.J. Thomson is a name. Not a name, but that's kind of how we kind of call him, J.J. Thomson. Don't know what his full name is, but, So Thomson proposed the plum pudding model for the atom. Now, the model suggested that the negative electrons were embedded inside a ball of positive charge, or in a ball of positive charge. Now, that's exactly what you have to say, kind of regurgitate. This part you can just pretty much regurgitate as well, kind of what... describe the plum pudding model. Well, you have negative electrons are embedded in a ball of negative electrons are embedded in a ball of positive charge. That's all you have to say for that, and you get your mark there. I think it should only be a 1 mark question, maybe 2. But you should get your marks there. But then, so the model suggests that the negative electrons are embedded inside a ball of positive charge, or in a ball of positive charge. He imagined that electrons were bits of plum, or electrons as bits of plum in a plum pudding. So that's what he kind of imagined it, Who proposed the plum pudding model? So the word's not coming out of my mouth today, I don't know why. But basically the answer is easy. It's J.J. Thomson. You could say Thomson, but to be safer, I'd say J.J. Thomson. It only says Thomson in the book, but it's better to say J.J. Thomson. And I think to remember it, because a lot of people actually call me JJ, just think of the YouTuber JJ. So JJ Thomson. That's a good way to remember it. I don't know why a lot of people call me JJ, but I'm calm with that. Anyway, so 10 years later, so this was obviously at the end of the 1800s. Then 10 years after that, Geiger and Marsden were experimenting with alpha particles. Now, which are dense positively charged particles, and they fired alpha particles at a very thin piece of gold foil. A few alpha particles were repelled, showing that there must be a central kind of positive charge. There must be a tiny positive charge in the center of the atom. And Rutherford, which is Ernest Rutherford, he then from this kind of proposed the nuclear model. So the plum pudding model was replaced with the nuclear model after that. So in the nuclear model, electrons are around the nucleus, which is the center of the atom, containing protons which are positively charged. So that's what that is. So that's what Rutherford thought after alpha scattering experiment. He proposed the nuclear model, and in that nuclear model, then we see that electrons orbit around the nucleus, which is the center of the atom, with the nucleus containing positively charged protons. So from that they got that kind of evidence, and they kind of used that for the nuclear model. And then what it is that Niels Bohr revised the nuclear model. He suggested that electrons were orbiting around the nucleus in energy levels, also known as shells, or energy levels or shells. The electrons were a set distance from the nucleus. They were specific distances from the nucleus. So he kind of revised the nuclear model, did Niels Bohr, and he said that electrons orbit the nucleus in shells or energy levels, and they're specific distances or set distances from the nucleus, which is positively charged itself. So the nucleus is positively charged. And so Niels Bohr's kind of theoretical calculations, or Bohr's theoretical calculations, matched the experimental observations. That kind of everything worked, everything fitted in his calculations and his observations. The kind of the theory calculations and the kind of experimental observations, they all kind of came to match together. Basically, they somehow matched together, and so it was kind of right, well, not right, but it was pretty much obvious. You could say it's right if things match together. But on the way up, so again, to achieve the top grades, you should be able to justify why the model of the atom has changed over time. So that's a kind of question they can ask, and you should know every single kind of timeline. You should know basically what events happened when, and basically how the model changed over time, and that could be a 4 to 6 mark in the exam. And so the study tip as well is a very good one, is to draw a timeline for the theories relating to the structure of the atom. So if you draw a timeline basically with all the events in your room, put it in your room, maybe where you kind of put it on the wall, maybe where you'd normally see it a lot. Sorry about the noise a bit if you can hear it. But basically, if you kind of looked at that, 5-10 minutes a day, kind of maybe spend time on that, learning it. Eventually, it will come in. It will sink in, and everything will become so easy. Like I've said before, if this question comes in the exam, and it's a very, very common question to ask, and especially if it comes, at a very for very high marks, if you know this, if you've learnt this properly, this will be a piece of cake. Literally, it's not that bad. It's just literally regurgitating what happens at every single kind of what happened first, then what happened next, how did we discover the proton, how did we discover the electron, the neutron, stuff like that. And here as well, so the keywords for today are electron, nucleus, proton, and neutron. And by the way, I didn't show you here. Here they got an image of Thomson's plum pudding model. So you can see obviously the negatively charged electrons, embedded in a ball of positive charge. Hopefully you can see that ball of positive charge. Hopefully you can see that over there. And so, yeah, they they show you that kind of this is your. They show you that this is the electron, this kind of green thing, and then the ball, the positive charge around that. So hopefully you can see that. But basically, now we're going to kind of end. But before we end, we're going to go through the kind of key points. And for the key points, I'll just change this over here 1 minute. So ideas about the key points are like. By the way, if you're following the student book, which if you don't fully know this content yet, I would kind of encourage you to go to the student book and kind of learn this properly. But yeah, so the key points are obviously because obviously this is for a basic overview, as I've said before. But basically, the key points are ideas about atoms have changed over time. Obviously we haven't kind of been fixed on one particular idea. Ideas have changed over time with experimental evidence, with calculations. Different things have kind of led to development in science, and then new evidence has been gathered by scientists who have used their model of the atom to explain observations and calculations. So obviously again, new evidence has been kind of gathered together, so they've been able to explain their theories and their calculations. And basically key ideas were proposed by successively by Dalton, Thomson, Rutherford and Bohr. And wait 1 minute. Okay, I've done something really, really bad. I shouldn't have done that. But basically, I forgot this, that in 1932, Chadwick, so after the Bohr's after Bohr proposed his nuclear model, Bohr revised the nuclear model, by the way. It was Ernest Rutherford who kind of proposed the nuclear model, but then it was Niels Bohr who revised it. And then after that, in 1932, James Chadwick kind of provided the experimental evidence that showed the existence of uncharged particles called neutrons in the nucleus. So neutrons and protons are in the nucleus, now we know that, and electrons orbit the nucleus in shells or energy levels. I'm really sorry I didn't go through that last point there, but other than that, I pretty much have. That obviously going through that last thing again from the key points was that obviously key ideas were proposed successively by Dalton, so that's John Dalton, Thomson, that's J.J. Thomson, Ernest Rutherford, Rutherford, which is Ernest Rutherford, and Bohr, who's Niels Bohr. And again, then after that, you can also add, Chadwick, or his full name is James Chadwick, who discovered the neutron. And now we basically know how kind of the structure of the atom kind of came about, which is actually the next section, how the kind of atom came about. And we know about the history, and we know about the history of the atom now. Although you might know about the structure already, it's quite a basic thing. But next lesson we'll be going through the structure of the atom, C1.6. This was C1.5 History of the atom. And so yeah, if you kind of found this video helpful, make sure to share, like and subscribe. And it's really kind of good, really supports me and encourages me to make videos every day. I'm really trying to make videos every day. And so far I've been able to, and so yeah, that's it. Make sure to turn the notification bell on so you're notified when I upload a new video for you to watch. And yeah, I'll see you tomorrow for the next one, which is C1.6 Structure of the Atom. And yeah, thank you very much, guys.